All right, good morning and happy Tuesday. I'm planning on doing the Leak Code Daily Challenge for today. Here we go, share my screen. And today is April 4th. So I don't want to look at my solutions. Okay, start from scratch. 6:22 in the AM. So it does look like I saw this one before. About a little over half a year ago. Anyhow, let's see what I come up with this time. It's always cool to previously solve problems because usually I come up with a slightly different solution each time. Partition them such that the characters are unique. Okay, so it sounds like we'll just use a sliding window. Right, so that'll be the game plan, right? Sliding window IJ, right, with a set of scene values for O1 lookups, right? That's the game plan. All right, let's implement this. So I, J, and N, 0, the length of S, while J is the N, and we'll keep track of T will be our total. We need a set to scene, be a set. If S of I is in scene, or S of J, scene, that's when we need to move the window over. So I equals J plus 1, J equals J plus 1 as well. Otherwise, if it's not seen, then we'll add it to scene. Scene to add S of J, J plus equals 1. Suppose we don't need I and J then in this case, right? So we don't need to really keep track of the beginning and the end. So let's just use I. It looks like N will only be used once. So I and scene. Okay. Let's do this. When it has been seen, then we'll create a new one. Start this off with 1 initially. Scene equals a new set in this case. And then we'll increment the total by 1. T plus equals 1. I think we can clear this, right? Clear it. This equals 1 always. Okay, so let's walk through this real quick. I think that looks legit. Is this guy, and then let's see. Oops, let's do this. Scene is an empty set. All right, so scene will be A. Just remove the text for simplicity. AB. Let's see, the total is initialized to 1. Okay, this A has been seen, so clear scene. Increment this to 2. need to add SMI into scene. So we'll add the A and the B, and then it has been seen before. All right, so increment the total to 2, clear scene, and then scene equals A. Scene equals AC. Okay, increment total is 3. That's just A. AP. A has been seen before. So that's 4. Okay, well, that's good. Well, and it's only used once. It's okay, that looks good. All right. 6:28 in the AM is about 6 minutes for the game plan plus implementation and Python 3, which is accepted. Yay. Okay, let's see what we came up with previously. Right? We don't need a sliding window in this case, right? All I did is just do a linear scan, tracking what's been seen. Seen. Yeah, for each character and ask, check what's been seen. Yeah, I like these previous solutions. These are pretty good. All right, cool. Let's see, I did it in Rust even, right? Yeah, so let's see what other folks came up with. Holy cow. What is this? This is junk. Who upvotes this? And look at this. Complexity is not intelligent. Simplicity is intelligent. Holy cow. It just shows you that, like, okay, this is fairly simple, but still, I mean, come on, really? If you make the simple difficult, then you make the difficult impossible, right? Simplicity is the ultimate sophistication. And it doesn't get much simpler than this. Maybe incident count, we call it T as a total, right? Which is what I came up with today. All right, and we can go through these real quick again, but this is, just think of this, like, what code would you want to debug? Would you want to debug this code? Who would want to debug this? And what the heck is this? This is junk. Oh my gosh, yeah, and it's just a good example. That popular opinion. When has it known anything? And why there are so many upvotes of that one? This dude's like a popular dude for some reason. I don't know. But anyhow, keep it super simple. Don't try to show off and be fancy or anything, right? Just it's frustrating, right? Even if I can simplify this more, which I can, like this, right? Each character and input string s. Then we don't even need to increment 1, right? So this is the easiest. Just there's our total, right? Anyhow, yeah, it's really frustrating to see. So many folks will probably look at these top voted solutions and be like completely confused. I would suspect, like, yeah. Okay, algorithms and data structures is difficult enough, and most folks are being shown, I think, poor examples of how to code. Right, keep it super simple. That's my mantra. But then again, what do I know, right? I'm still a work in progress. We got this guy, a little bit easier, I think. Total T. When we're in a linear scan of all characters C of the input tree dash, tracking which characters have been seen to accumulate the total, right? The total T sum of partitions. Right, okay, so let's just clean this up a little bit. We'll write them from scratch in each of these languages for practice. Oh, what is this? Reset to the default code. Okay, so for using set as an on-ordered set of characters, set scene, T is our total, which will return the end here. If scene insert C dot second, we can't do it. That's when we'll clear the set. And increment the total. Total is initialized to 1. Oh, that doesn't look right. Scene equals set of just that character. Keep it super simple. It's good. It's cool. Okay. JavaScript. Oh, by the way, I should mention what this is doing, right? So when you try to insert into a set in C++, it returns a pair. The pair is the first of the pair is an iterator to the newly inserted element or the element which already exists in the set. And then the second of the pair is a Boolean. It's true if you're able to insert the value C into the set scene. Otherwise, it's false if the value already exists. So that's what we're checking. Does the value already exist? And it does in this case, if this is true, and we'll create a new partition to increment our total T. Okay, anyhow, let's do this here. Scene is a new set. T is our total. Initialized to 1, which will return at the end here. Or let's see, a vested split. If scene has C, then recommend our total, and scene clear, and scene add C. It's good. Did our total initialized to 1, which will return here, and then scene, it will be our set, mutable set of characters for each character in the string. If scene contains the character, then we'll increment the total, and scene will be cleared. Scene add the character C. Right, just a linear scan of the input string S. Nothing too fancy. Keeping it super simple. Rest, okay. Must be the last one. mutable t is initialized to 1, we'll return t at the end here. And then for each character and as chars, iterate through that guy. We need to keep track of what's been seen. Be a hash set. Hash set new. If scene contains a character, increment our total, then clear scene, scene.insert character. And the ownership still within the characters of S, right? Okay. Take ownership of it. Okay, that looks good. That's cool. Okay. That's all she wrote for the daily challenge. And it's been my experience that it makes sense to keep it super simple, not only for my own understanding, but for others as well, right? So go do a linear scan of each character, input string S, use a set, an unordered set of characters for O(fun) lookups to see if we already have it, seen it. And if we have, then we create a new partition, right? So increment our total T partitions by 1. Right. Keep it as simple as possible. Okay. Catch y'all later.